morning, guys. So we're gonna solve this problem. Okay, first. Okay, what is the input? Yes, alpha, right? But it's in this problem, there's not that much of a vocabulary, right? Saying that this is the input, okay, and but it's I mean, you can think of, okay, so it's something given to you like alpha, so that means though that particular word is not there, it's actually um, going to be an input. Okay, all right. So let me start this. All right. So this is a kind of a brain teaser, um, but it involves some thinking and some math. Okay, so let me actually I couldn't reset this one though. Anyway, I'm gonna copy this. Oh, I need to actually select this. This is my workout actually. So I'm gonna redo it, guys. Okay. Oh, all right. So I did this. So and this is what we have. So this is the analog clock, right? So and you can see that um, there are 12 segments here, right? Right. So there are 12 segments. Okay. So let's take um, 3 o'clock. Okay. So I'm going to draw the hour hand. Okay, like this. It's at 3. It's shorter, and at 3. Okay. Let me give. I'm gonna use green. Okay, because it's St. Patrick Day. Okay. All right. So, all right. So start. Imagine the start of the hour is 3. Okay. So that means the current hour is 3. My question is, where should be the minute hand? Yeah, at 12, right? Minute hand should be at 12. So every start of the hour, minute hand at 12, right? So let's draw that. Okay. Okay. So and then this problem, like you will see that by drawing this diagram, going to unravel a lot of things. Okay. So this is the minute hand. Okay. Now, what happened when the hour hand goes to 4? So basically, minute hand goes entire 360, right? Right, entire 1 hour, right, in the entire 360, and then come back to 12 again. Okay, all right. Imagine the hour hand comes to like right at the center between 3 and 4, right, like right here, right. So I'm gonna do like broken lines right here. So this is where the hour hand is going to be, right at the center between 3 and 4. Where should be the minute hand? At 6, right? So minute hand is going to be somewhere here. Okay, so the amount of rotation is, how much is the rotation? This angle 180, right? That angle is 180. Okay, so that's going to be 180. Okay. Oh, this one's not working. All right. So this is going to be 180 degrees. Okay. All right. So, so let's do some math. Okay. So what I want, so now, like if we take this angle, so what is this angle? Okay, let me first what is the angle between, I'm gonna mark two consecutive hour signs, right? Let's say, let's use this this. Okay, so I'm gonna connect 9, and then also connect um oops, and connect 10 as well. Okay, what is this angle? What is that angle? Angle between two consecutive hours. What is that angle? Um, no. How can we find that angle? Let's say this is no. This angle is small, right? This one? No. 15. Did you say 15? No. The angle between, so how do we calculate that? We can, there's a way to calculate that angle, right? There are 12 segments, right? Because there are 12 hours, so there are 12 such angles, right? What is the total angle at so basically so basically when our hand, let's say the our hand move from 9 to 10, the minute hand goes single one round, right? That's 360 degrees, right? So it basically goes all 12 segments, that's 360 degrees, right? So then the angle between two consecutive segments is going to be, yeah. So so basically imagine, so right now we have our hand over here, right? But imagine our hand is 9 and it moved to 10, right? And the minute hand all goes one round 360 degrees, right? No. So the question is, my question is this, right? What is this angle? So angle between if I join 10 to center and 9 to center, like there's a tick mark over here, right? That to the center and then 9 to the center. If I to join those two line and there's an angle over here, this angle 30, right? Why? There are 12 segments. It's 360 divided by 12, right? So basically this angle equals 360 divided by 12, because there are 12 segments. See that? 1, 2, 3, all the way up to 12, right? So that angle is 30. Okay. So these are the facts. Basically, you are basically applying your domain knowledge, right, to find out few things. So this is 30 now. Okay. And this is a fact. It's 30 degrees. Okay. All right. So now let's go back to here, this situation. So the hour hand is in between, right at the center of between 3 and 4. Okay, so right here. What is that angle? This angle, this angle, that's 15, right? So it's 15. Okay. So let's do some math then. Okay. All right. So here's what I'm going to do. So I'm gonna okay. All right. So when our hand move from current hour, start of the current hour to the start of the next hour, right? Minute hand moves one round, right? 360 degrees. So let's write that down, okay? So our hand, so I'm gonna this kind of a table, guys, okay? And moves 30 degrees, okay? That means from 1 hour to the next, okay? Minute hand moves 360, right? So 360, okay? So, and then you can see that these are two ratios, but these has to be constant, right? So I mean, um, the minute hand moves little bit faster pace, but constant pace compared to the hour hand. Okay. All right. So now when the hour hand move 1 degree, so okay, how much the minute hand moves? So if it moves 30 degrees, minute hand moves 360. If it moves 1 degree, then 12, 360 by 30, right? So 360 by 30, sorry, yeah, 30, right? Sorry, 30, which is right, 12, okay. All right. So now, so this is a revelation, right? So when the our hand moves, we are kind of proving this backward, okay? Our hand moves 15 degrees then, okay? Then what's the answer? Yeah. So basically 15 times 12, right? So what's the answer? 180, 180, right? 180. It's 2 times 90, right? So 180. And then that's what we actually have over here, right? See that? It's right at the center of the, right at the center. 15 degrees means right at the center between 3 and 4. And the minute hand is at 6, 180 degrees. Okay. So, so then the question is basically, if we can, so this is a scenario that the problem asks, right? Right. So problem asks, right? The problem asks, right? The hour hand of an analog clock turn alpha degrees since the midnight. So what is that? Midnight means, so oops, right? Midnight means 12, right? So this is alpha. Okay. So this is going to be our alpha right here. Okay. So this is going to be our alpha, the whole angle, because midnight is 12. So this is going to be alpha. Okay. All right. And since midnight, determine the angle by which the minute hand turns since the start of the current hour. So, so what's the start of the current hour? Is 3, because we are in the hour 3, right? So start of the current hour 3. Okay. So how much is the minute hand move? So we're basically asking this angle, right? So this, let's say this is beta. Okay. So beta, we found that it's 180 degrees. Okay. So basically beta equals 180 degrees. Okay. All right. So then all we need to do is, see the problem asking what is beta, right? We found out is 180. Factually, we found out 12. the minute hand moves 12 degrees, right? So these are all degrees, guys. Okay. um, right. uh, um, 12 degrees, sorry, this is, oh, yeah, um, per 1 degree movement of minute, our hand, right? So see that our hand 1 degree movement, we, it's equivalent to 12 degrees of minute hand movement, right? So now for 15, we found that is 180 degrees. So beta is 180. Then if we can find this value, well, problem is solved, right? All right, then question is, how do we get that this angle given the alpha? So alpha here is, so this one, right? So 90 plus 15, right? So the alpha is actually, so when we write alpha's value, alpha, so this is given, alpha equals 105 degrees. Okay, so given 105, how do we find 15? And then that's mechanism going to solve the problem. How? Right? So the alpha is, this whole angle is 105. Okay, but we know that we get the correct answer beta 180, right? If we get if 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 we can find that angle in between angle, right? So this angle, this small angle, right? 15, then the answer is, just multiply that with 12, right? 12 is a fact, right? Then you get 180, right? That's beta. Okay, so then given alpha, how do we find 15? It's going to solve the problem. Okay, ideas? So that's where the math we need. Okay, so basically here's what we need to do, right? So you are given alpha, you need to find the angle between this, like this angle, right? So this is the current tower, right? Here's the next tower. So we know that this whole is 30, right? So we need to find this angle, right? Always. That's what we need to find. How do we mathematically find it? Ideas? Yeah, modulo 30, right? Because see, so all of these are 30, 30, 30, 30, 30, right? 12 30 is there, right? So we need to find this rest. So this, let me take it back, right? So 3 means there are 3 30s, right? Whole 3 30s, 3 o'clock, right? So 90 is 3 times 30, right? So 30 here, 30 here, and 30 here, right? And then if we come to this 120, so the values are basically in between. So to find the rest given this whole angle, we need to get the remainder of division by 30, right? So the alpha basically, so that's, that angle is going to be, right? So alpha, so basically here 15 equals, right? So 15 equals 105 modulo 30. Okay, and that gives you, so 15. Okay, and then to generalize this, to find a pattern, right? So basically, so the angle, so what you need is over here, right? So alpha modulo 30 times 12 is going to be your answer. Okay, so like this one. Okay, so we are generalizing this one. This is a particular example. Okay, and here's the generalization. So alpha modulo 30 times 12. Okay, and that's it. This is the answer. Okay, so alpha is the total angle from the midnight to the current hour position. Okay, and then if you take the modulo 30, we'll get that the residual angle, right? So right, like this much, right? And then and that times this factor gonna give us the answer. Okay, all right, clear everyone? Okay, so let me know. Okay, so I can go one more time as well. Okay, so that's where the you know figuring out that pattern is the trickiest part, and basically the teasing part here, right? But the rest is, like, the analog shape is elementary mathematics, right? Math class, and then the module operation probably, think, ninth grade, I guess, right? So it's that, right? So it's that thinking that, right? So this is actually going to get, so all you have to do is get this picture and do some drawing, and then um, ask yourself few things. Okay, so without that it's really hard to think actually. Okay, all right, so kind of difficult to think. Okay, all right, so let's write out an algorithm for this. Okay, so what are matches for this one then? We have three matches, right? We have used modulo in several problems earlier, right? One is swap first last, right? And then reverse, and generally modulo operation. Okay, all right, and then let's write the plan. Input is the alpha, right? Input, I'm going to say um, our angle, right? um, our angle, not alpha, um, from midnight, since midnight. Okay, all right, that's the input. And step 1, 2, return this value, right? So this one, modulo 30, sorry, and times the whole thing times 12, right? So basically pretty much one fact you will use it, basically the 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 amount the hour hand move to the minute hand move is proportional. That proportionality is a constant, which is 12. Okay, all right, so now let's solve the problem. Okay, so def um, I'd say get angle. Okay, so the input is going to be this, and return, so turns the angle by which the minute move since this. Okay, all right, so for, I would say 4. Okay, all right, so simply return this, right? All right. Okay. So I'm gonna take a new name for the variable. So our angle, and then I'm gonna call the function and print it. Let's see, our angle is going to be this, and then I'm going to change this to, let's try with um, 105. Okay. All right. I should get 180, right? So I got 180. So I'm gonna actually add a print here. Okay. All right. And let me add more values. More. Okay. Let's call for um, well, 360. All right. So 360, I should get 0, right? Because it's a full round, right? So minute hand at 0. Okay. So let's put 0 as well. Okay. That's also 0. Okay. So let's get some in between values, like let's say um, um, let's say 110 degrees. So it's 3 something, right? So I got 240. Is that, did I make a mistake? Correct, right? 110 degrees. Oh, let's see, angles. Well, let's take a look over here. Sorry. So this is 90. Yeah, yeah. Okay. So it's between, like, 3 and 4, close to 4, somewhere here. Okay. Yeah. All right. So yeah, 240 degrees. Okay. Any question? But you got the answer. Okay. So and then you can see that, that this application is the way. I mean, this how we can generalize to any answer, right? So we to the way to find that residual between the whole hour, starting hour, and then the ending hour. Sorry, starting hour to the current location of the hour hand is coming from this, actually this math, right? And then times 12 means this is the ratio between the speed of the hour hand to the speed of the speed of the minute hand to the speed of the hour hand. That's the ratio, 12. Basically, minute hand is 12 times faster than the hour hand, right? It goes single round when the hour hand moves 30 degrees, right? Okay. All right. So that's that. Okay. So without this fact, we cannot actually get without finding this fact, we cannot actually solve this problem, in fact. Okay. All right. So how can we make this one default to what? It's the improvement default to 0 degrees. How can you make the angle alpha, which is this one, default to 0? We discussed this last week, the default parameter. So default this angle right here. How do you make it to 0? Default to 0. We do it right here, right? So equals 0. Okay. So now, right, now basically if I omit, let's say I'm gonna call one over here without giving any, it's now gonna take the default value 0, and then it's not gonna complain, right? If I don't have it, if I don't have it, see that it's going to complain, right? See that, saying it's a type error, saying it takes at least one parameter, but you are not giving any, right? But if I do this, right, do this, it's not gonna complain, okay? Because it's gonna, I didn't submit a parameter, but I'm saying, hey, if I don't submit, take the default value to 0. Okay, that's what it actually did over here. Okay. All right. So let's quickly go over the questions. Okay. 5 question. Write a statement other than an assignment statement you use in your code. What is the statement other than assignment statement here? Yes. Print is not a statement. Some, it's some, in some languages it is a statement, and sometimes we generally say it's a print statement, but print is a function call. Function calls are not statements, they are expressions. So there is another type of statement over here. We learned it actually quite a while ago in week 5. The return statement, right? So right here, okay, return statement. All right. And then what's the next? So the write an operator you used and the respective operands. Okay. So, yeah. Okay. Um, so if you take this one, what are the operands? This and this, right? Okay. If you take this multiplication as the operator, then this whole thing is one operand, and this 12 is the other. Okay. Write an identifier type token other than a variable name you use in your code. Okay. So what are identifiers? Those are the names we give, right? We use, right? That include variable names, module names, function names. But it asking a name other than a variable name. What is that? A name other than a variable name we have given. So these are all like variable names, right? This one right here, these are variable name, right? A name other than a variable name. We don't have turtles here, right? So function name, right? So this function name, that's this one, and then main also one, right? So but this is the one that I was expecting. So it's a name other than a variable name we use. Okay. All right. So next one, the two punctuators type tokens you used. Punctuator type tokens we used. Two of them. What are they? Punctuator type, like delimiter type. Is this a one? Is this a 1? This is not a 1 because this is an operator, right? It's not a punctuator. This is an operator. This is also an operator. Okay. If you take this colon, that is a punctuator. Okay. That's 1. There are 3 over here, I think. This pound sign is a punctuator. Okay. And then this triple quotes, it's also a punctuator. Okay. So it's a, all right, there are 3. All right. So 2 punctuator type tokens you use. Write the formal parameter and the respective actual parameter. Okay, so what is the formal parameter here? Formal parameter? This guy, right? Yeah, this angle, right? What is the actual parameter respect to? And any of these, right? Any of these are actual parameters, okay? All right, so let's move on, guys. All right, we're gonna start module 8, okay? Before moving to module 8, okay? So midterm period is over by now, okay? So I know some of you guys haven't submitted midterm yet, but you can still submit anytime between now and the final week, right? So you will still not get a penalty, but you can still submit, right? So my deadline to submit your midterm grade is 22nd, I think. Okay, so like next week. So what basically so uh, going to your midterm grade is um, any any assignment that were due before the last day of the midterm is going to go into your grades. Okay, that means basically, so we just started module 8, so module 8 not going to get counted. Okay, so until this point your grade will be calculated, the midterm project, right? So we finished module 7, right? So that's what's going to be. Okay, all right, so let's begin our new lesson, guys. We are starting chapter 8. All right, so we already encountered math module, right? Oops. Okay, all right, so let me open the Colab. Okay, all right. All right, so I'm going to import math module. So you'll have to actually to use. So pretty much every programming language provide a math module because obviously, right? In computing, we tend to do a lot of math operations, right? So and then for that reason, we need to have reliable math module. Okay. So in Python also we have that, and we call it import. And so math module. So we use import. So we import that. Okay. All right. I want to find out the content of math. How do we do that? How can we find out that? I want to find out the set of attributes inside math module. How do we do that? So how can I find? Of course, I can actually Google it and go to the documentation and find out how. Right? Imagine I don't have internet, but I can. How can I find out here the content of math module? We learn a function for that, right? What is it? it's the directory function, right? So if I print dir, right, and then math, right, it's going to give us a list of attributes available from math module. So basically entire content. Okay, and you can see that, right? So it's a list. You can see that it's starting with the square bracket and ending with another square bracket, right? So that means a list. Okay, and you can see the things inside, and then you can see it's a there are those names are literals, string literals. See the quotation, right? So, but they are those names are in string literal format, and you can see that this internal names that's starting with a double underscore, right? Remember we talk about them, right? So we don't use those kind of naming regularly in Python for regular variable names, right? And then when you move on, right, so you can see that there's sale, there's cost, sign, those kind of math functions, right? And even constant like e, the natural logarithmic value, right? And then pi, the pi's value, 3.14 thing, right? Okay. All right. So and then there are a bunch of math modules examples or functions over here. So let's take a look at the ceiling function, right? So it's round up the value. Okay. So if I'm gonna use pi, right? So let's say print math.ceil, all right, and then I'm going to use math.pi. Okay, so that's pi's value. Okay, and then if I print this one, I got 4. Why I got 4? Why I got 4? Yeah, it's rounding up, right? Otherwise, it's pi's value, right? So if you print that, basically you get 3.14, right? So it's rounding up. Okay. So if I use the other function, the flow, right, it's rounding down, right? So um, if you use the flow function, okay, it's rounding down, so I get 3. Okay. All right. So all right. So there's a whole bunch of math module functions available. Okay. All right. Random numbers. Any question, guys, before we move on to random numbers? We already encountered random numbers too, right? You sent this one, right, Matthew? Matthew, right? You're Matthew, right? Okay. Yeah. Yeah. So this is, guys, this one example. Sorry. You're okay to show them, right? Yeah. So this is Matthew's GitHub project. And then you can see that he did his full one-page resume using the template, right? And then you can take this with you and modify, add page, add photos, add links. It's up to you. You can add interaction as well, right? I suggested adding a Google form over down below to collect feedback from people who actually you know read your resume, right? So you can do so, like if it's a Google form, and then you have access to Google form, and you can say who actually watched or read your um, thing, right? Your resume. There are a lot of things you can do. I mean, this online, and if you add, you can add interaction. You can add, you can make this click and then flip. There are many things. These are ideas, right? So that's the JavaScript. There are a ton of JavaScript, free JavaScript you can find from internet, and you can ask, okay, how can I flip a photo in an image? And you don't have to write code. You can get code from the internet, right? So try your own. Say, take it away with you, and make it your permanent online resume, right? That's what one of my goal by making this project for you guys in the midterm. Okay. All right. Let's watch our video today, guys. Um, it's this one. Okay. So I just published it, guys. Procrastination. It's on module in module module 8. Okay. All right. So let's watch. So let's continue. All right. Random numbers. So we already use random numbers, right? So um, right. So you can see that games are the places where we need random numbers, right? Like game program, right? So rolling a dice, right? Or website generating a random password, right? So it's random, right? And sometimes and you may have played video games, and then kind of you see that the let's say the demon appears randomly in the screen, like no, you don't see where it's actually coming. So the demon enters randomly so that you can make the game interesting, right? So and then there are a lot of places where in video gaming they use actual random numbers. Okay. All right. So it's the random module. So we import the random modules, and then we can use this function. So first one is random. Just actually generate uh, a number between 0 and 1. Okay. So it's a floating point number. Okay. And then we already learned, and then you can see that it's actually exclusive. So the one is not included. Okay. And then we learn later, like like earlier, right? We run int and run range, right? So let's open random module. Okay. So import random. Okay. And let's print the random random. Okay. Random. Okay. So you can see that it's actually going to give a number between 0 and 1. 1 is exclusive. Okay. And you can see that every time you run it, you get a different number, which kind of indicates randomness, right? So you can use, we have been using rand int already, right? So rand int. Okay. So the range is basically, let's say 10 and 20. So both inclusive. So we'll get a random number between 10 and 20, right? Okay. So like this one, right? Okay. And if you use rand range, right? So I'm going to use rand range now. rand range, and let's say let's say 1 and then 100. Okay, and then for rand range, this last input is not inclusive, so it's exclusive. Okay, so it's not included, so you'll get like this, right? Okay, so but in the same rand range one, if you use a step value like 5, right, you'll get a random number. It's still random, but in steps of 5, right? So you will not get odd numbers like 66. You'll get a it's a multiple of, it's going to be multiple of 5. Okay, like this. Okay, no in between values. Okay, so this we call the step value. Okay, I think we actually kind of use that in the random popping circles in RGB values. We put gaps between RGB values, right? All right. Okay, so all right, I think we can, yeah. Okay, so okay, so if we let's take go to reality, like physical world, right? If we make a if we throw a dice, right? If we throw a cubic dice, right? We know that the outcome is random, right? So one of the side, right? So from 1 to 6, right? If we throw a coin, that's also random. It can be the head or tail, right? And we cannot basically, we can try to predict, but it's random, the outcome, right? So Mike, I have a question. How come computer give us a random number? Because it's a um, deterministic machine, right? So basically what computer does is what we actually tell it to do, it actually do that, right? So then how come it's actually, so if we think a number in our brain, that number is random, right? I mean, almost, I would say, right? But if we ask the computer to think of random number, right, it can only follow our instruction, then how come it be random, right? That's something, right? Because the computer runs always an algorithm, right? So a recipe. So when the random number is the outcome of that recipe, then how come it be random, right? It would not be, right? Because it's coming from a algorithm. And in fact, they are actually not pure random numbers, and that's why we call them pseudo random numbers. Okay, pseudo random numbers. Okay, and there's a proof for that actually. Okay, so let's try to prove that. Okay, so what I'm going to do is I'm going to, okay, use this function called random dot seed. Okay, all right, I'm going to set the seed value to, let's say, 100. Okay, and then I'm going to do all of this, let's say this one. Okay, or you can try all of them. Okay, let's try that. Okay, all right, let's see what happens. Okay, guys, so all right, I got this right. Okay, so run one more time. Is there randomness? See that randomness is gone, right? Every time I run, I get the same set of values. The randomness is gone, so it's not random anymore. All I add was I set the seed value to 100. This is to indicate this is actually not a pure random number. It's basically well, coming from a recipe or an algorithm. Okay, so this is the actually proof. If someone asks, okay, can you prove that the pseudo random numbers are not actual random numbers? Here's what you have to do: show them whatever that is, whoever that is, right? So basically, see that it's coming, it's giving us the same value, right? So every time we run it, so random number is not. So this is basically the proof that yeah, the computer cannot generate pure random numbers. It's actually use a formula or algorithm to generate them. There are a whole bunch of them. Okay, so okay, so then all right. So if we don't use an input to this seed, look what happened, right? So right now it's gonna be different. See that? So there's now randomness there, right? So what's going on then? So then there should be default value kicking in, right, for the seed. So what is the default value for seed then? Well, computer cannot generate a pure random number. So how come it now give a random number to that one, right? It's not. So there's something. So you can see that if we change the seed, right? I'm going to change 200, right? So let's say I'm going to add 200. I'll get a different set, but they are also not going to change, right? Right. So, but it's a different set. See that? It's a different set, but still it's going to be the same because this guy is already 200 always. So then one trick to get something different always, like something at least random always, is to change this seed, right? Constantly, right? Constantly changing the seed would work, right? What is the best way to change that constantly? So use something constantly changing, right? In there. What is something that constantly changing? What is it? Ocean? Yeah, good choice. But how do we input to the seed? Quite good idea actually. Any ideas? Any more straightforward ones? But yeah, you are right. I mean, yeah, the waves are random, right? So you get something out of that wave fluctuation and feed it, and yeah, there you go, right? But there are more, I guess, reliable techniques. What is constantly evolving? I mean, if we can put something constantly changing that value in the seed, we'll get something like different always, right? Like this some random there, right? But what is such a thing? Do we have? Do you know? Do you guys know? There's such a thing constantly changing, constantly increasing. There you go, right? Time. So the system time is actually measured in, I think, probably nanosecond, maybe second, nanosecond, let's say. Like, it time evolves, right? Time increases, right? So if you set a starting point, the beginning of time for the computer is, I think, 1970, January 1st. We call the epoch. So it's not the Big Bang, okay? So for the computing is 1970, or that's what they said. So from there, there's a timer always ticking it. So if we can feed that value to seed, well, we are changing it constantly. Okay. So by default, the seed function. I mean, every programming random module has a seed function pretty much, not just Python. Okay. They set it to the time, actually system time. Okay. And then I think it's in second probably, or maybe nanosecond as well. Okay. So that's why if we do not actually put the one, it's basically going to use the time, and we get always different set of values. Okay. All right. Um, all right. Let's do this one, guys. Um, Using a unique seed for each program run. In the absence of seed being supplied initially, the expression random.rand int x comma y yields a different integer sequence with each successive iteration. Is it true or false? True, right? Well, it can be same as well, but usually it's true. Okay. All right. And the last one, rand int generates a pseudo random sequence of value because the sequence begins repeating itself after about 20 numbers. False, right? Yeah. Okay. There's no such thing, right? Okay. So so the reason why we call them pseudo, because these are not real random numbers. Okay. There's an algorithm. There's one common algorithm is actually we call Mersenne twister. You can Google it. Mersenne twister. I think the guy's name is Mersenne. It's a mathematician who invented the algorithm. There are a bunch of such algorithms there, all right? And then yeah. Also, okay, so let's talk about the uniqueness. Okay, so let's say like this, let's take this example, right? So this one, okay. Here's a question. Um, what is the like? Okay, so there are like between 10 and 20, there are 10 numbers, right? Then 10 possibilities, random, right? 10, 11, 12, all the way up to 20, right? So what is the probability of getting each number? Are they equal or different? Equal, right? They are equal actually. So when they are equal, we call the random number generator uniform random number generator. So the probability of getting a random choice is equal to all possibilities. Right? So we call them uniform random number generators. That's actually terminology. Okay, so it's really important. Sometimes when you want to, like, let's say like calculate these probabilities, like simulate something based on a probability, then depending on your choice of the random number generator, important. Okay, so um, if usually by default, this regardless the language, actually by default the random number generator is actually uniform, so we call it uniform random number then. Okay, there's equally likely that each random possibility you get. Okay, so and then there are other probabilities, right? So for example, if I want to um, simulate, let's say this is this is a big class like 100 students, right? I want to simulate the height distribution of students. What kind of a plot will I get? Yeah, normal curve, right? Or the bell curve. But it will have how many humps will it have? It will have two humps. Why? The Because, well, in general, women's height is more like by average compared to males. So then, and if there's both male and female in the class, you're gonna basically get two, right? Two humps. So that basically, if you only have one gender, then it's a pure simple bell curve, right? So If I want to simulate, let's say, class of 50% women and 50% men, like 100, can I use a uniform random number generator? No, because the distribution is in the bell curve. So you have to actually use the Gaussian distribution, which is the one that we call normal distribution. Okay. So why we call it normal distribution? It's because many physical phenomena are actually behaving like that. So it's normal. That's why. So like height distribution, many things in the real world behaves normal curve, like bell curve shape. So that's why they put it like normal curve. This is the normal behavior, so normal curve. So if you want to simulate that, then you have to actually take your distribution, the random number distribution that you use into that probability curve, whatever the distribution curve, in this case normal curve, right? So in with that regard, you can actually, in fact, you can actually generate random number based on a distribution. And here's for Gauss, right? So you can actually use Gauss, okay? And then you can then generate. Now basically you generate Gaussian distributed random numbers, not uniform distributed random numbers, okay? So but this is something advanced topic for you guys. It's not for this class, but it's good to know that there's a distribution type for the random number. If it is uniform, there's equally likely every random possibility come up randomly. But if you follow, let's say, Gaussian distribution, then the random values will come up based on the normal curve, okay? All right. And in log normal, there are other as well. So I think this log normal is the way kind of the stock market behave. Okay. All right. I think we can stop right there, guys. Again, we can continue from this topic uh, Thursday. All right. So with that, I'm going to open the today's problem. Okay, this one, minimum disks. So this one also doing all this one also similar to what we have been doing for now 3 days, including clock phase, the swap first last, and then the reverse number. They all use the modulo, and then uh, um, also integer division, right? So the reason is I want you guys to get practice doing this weekday number assignment. Okay, so all of this will be good practice for doing the programming assignment of this module. Okay, all right. Okay, so it's published, guys, right here in module 8. The this one. Okay. Oh, I think I need to open it. Minimum disk. It's in module 8. Okay. And you guys need to do couple of examples as well. So this one will be really helpful if you do 2 examples, and one is given already. You can work out that one, and then one more of your own.